Alright, are we ready? Alright. Hello everybody, my name is Bryntse. I've flown here from Sweden today to meet you. Thanks everybody for coming out. So, briefly about me, I'm not going to bore you. I'm from Stockholm. I've worked with web and XJS since about 2007. Before that I was doing a lot of C#, and then I found JavaScript and XJS and I couldn't get enough of it, so eventually I quit my job and founded Bryntum in 2009 so I could do full-time XJS and JavaScript, and that's basically the story ever since. So we make components and tools for the Sencha ecosystem, add-ons, visual components, and if you want to know more you can go to our website or Twitter. And I hope you all saw the plug I did for Nordic JS, which is a conference coming up this September in Sweden. It's the first, I think, big JavaScript conference in this region, so I hope you all go there and check it out. It should be very cool. So the agenda for today, I'm going to speak mostly from my own experiences here, so it's not stuff I made up, this is stuff I've actually lived. The challenges we had as we grew our company, our continuous integration process. By the way, do you all know what the word continuous integration, what that means? Hand up. Alright? So it's basically a managed way of doing software delivery and keeping control over the whole process. So we're going to show you how we do things and how we eventually ended up building Siesta, which is a testing tool for both unit testing and UI testing, specifically targeted at JavaScript and Sencha frameworks. Talk a bit about how we test our code, do sanity tests, quality tests, and what monkey tests are. It's quite cool stuff. How we log errors, pre-commit hooks, and how we do testing inside of the IDE. So, got quite a lot of content today, so we're going to try to move pretty quickly. And I know you want to get home because it's late. So, some of the challenges we faced at Bryntum, so when I started it, it was only me. So that's already a quite big challenge because you have to do everything. So, limited resources, that's quite obvious. And as a product company, we want to focus on product. We don't want to get lost in the whole process, that just have to work. We also have a distributed team. We're in 4 different time zones. So that also is quite a big challenge when you can't just tap someone on the shoulder to discuss things. As for any web developer, we are faced with multi-browser. That's why we use libraries like jQuery or X or Angular. We have multi-OS. If you are like us, you deal a lot with dates, then you have to worry about daylight savings in different time zones. That's quite challenging as it turns out. If you make components, like we do, you have to worry about different versions of XJS if you want to support them, because they change. That means you have to adapt. And as any developer, you want to kind of have a sense of what the health is of your product. Like, are we fit for release, or is everything just broken? That's one thing that I like to know. And we had a really long release cycle in the beginning too. It's maybe like one new release every 5 months, which makes it very cumbersome, too big, and too much fear with every release. And we had no bug tracker in the beginning either. We just had people complain loud in the forums, which also wasn't such a smart move, it turned out. So that's a list of challenges that normally you would just approach that building a very solid continuous integration process. So what was our continuous integration process in 2010? Well, this is it. So let me know when you've finished reading. Right, so we had nothing. That's the whole point. So we're pretty much on the epic fail part of this scale. Not really realizing it, because we're so busy fixing bugs, just fixing regressions, testing, make sure we don't accidentally cause a bug to appear the 3rd time after the same client has reported it twice. That's typically quite embarrassing. So this is really the best picture I like about software development, that we are always so busy that we don't ever take the time to say, hey, we're doing this like idiots. We need to be smarter about our time, especially in a small team where you don't have the time to do manual testing in 10 browsers. This is the perfect picture, because you're so stressed up all the time the release comes, you're even more stressed. But with the right tools, plenty of automation, it comes a whole lot more pleasure to do software development. And yeah, at the end of the day, you'll be this guy. That was me the first 2 years, really frustrated until we got to where we are today. So fast forward a bit to 2014. We now have a solid VM farm where we can do automated testing of different environments. We don't have to sit and click around doing the monkey thing, see if it works. For all our products, we have about 12,000 assertions, which runs twice a day, and just for now just posts the result to us in text form. So we always know on any day how we're doing. We see for every browser, for every OS. We also work on a TeamCity suite, which should be up by next week. So we're going to actually publish all our test results live on our site. So any of our clients can go onto our site and say, hey, how is Bryntum doing? Is the nightly build looking pretty fresh, or is it just devastated? We have a public bug tracker where our clients can go and just give us tickets and track them. We have monkey tests of all our code base, so just to find undetected things that we didn't think about in advance. That's very easy to do monkey testing, actually. We wrote specific tests to handle these daylight savings issues. So we were getting bug reports from Brazil for some reason, and we couldn't really figure out why Brazil? Why didn't Moscow or Berlin complain about this bug? And it turns out in Brazil they have a DST switch. When they switch daylight savings, they actually switch the date as well. So at 2 a.m. it goes 2 hours back or something like that, and the actual date itself changes, which is kind of not so great. But yeah, so that took a while to figure out, and how to realize how to test that was pretty challenging. But again, virtual machines to the rescue. So our farm now runs a specific subset of our tests in 36 different time zones. So you can see this is actually copy-pasted from an email. So we're testing it in Pacific Mexico time, Central America, Canada, US Mountain time. Just all these time zones, that's done automatically every night, every day. So that's also very nice to have fixed. We also use pre-commit hooks so that we can't commit really bad code into the repo, destroying the day of our fellow developers, because they should be our friends. They should not fear us. Like, hey, is Mike working today? Okay, I'm going to take the day off. That should not be what people say in your office. And all the releases we make now are automated. So nobody has to really be in the office at all. They can just go online, some SSH client type release, click, and that fires off all the tests we have, and does a bunch of smoke tests. And the actual test is done on the package that's being released after we build. It's not being run on our source code repo, but the tests are actually launched on what's going to be released after it's been built, just for extra verification. And to push this to the extreme, I don't know if you can read this, but this is our last release previous week was done by me in a cafe from this awesome machine, my iPhone. That's how I did the release. And this is the actual screenshot that I made. I don't know if you can, if I zoom in a lot, you'll see we're pushing the release number from 2.2.16 to 2.2.17. And you see all the steps that are being done from our automatic script. So I didn't do anything. I was drinking coffee, chatting with a friend, and the release was just happening. And if there was a failing test, the release would be blocked, of course. Luckily, it wasn't. So, moving on the awesome emitter, we're pretty close to what we want to be. We got a bit more of transparency, so we can have all our test suite published live. That's where we want to be, and we'll be there pretty close, maybe a couple of weeks. And this is how you feel when you have this in place, because I've been in both places, and yeah, I think I smile more now, I sleep more. I think my friends contact me more often. So I don't know, it just makes you feel a lot better. So the whole solution for us to get to this was to have a very good testing tool. So test is the backbone of us being able to function with so few resources. So we built our own called Siesta, which looks like this. If you've been testing with other tools, it won't look very shocking. On the left you have a tree with your tests, basically your test suite. In the middle you have your assertions or your results, your expectations. And if you're doing a UI test, you can also have a special DOM panel where you can do investigations of the UI. So this is what we do every day, basically. A few buttons up there. We can inspect the test source code. You can toggle if you just want to see failed assertions. You want to swap over to the recorder, toggle some settings. We also have a component inspector, etc. So you don't really need a manual for this tool. So a few basics about Siesta. Each test in itself is sandboxed. It runs in an iframe. If you've used other tools like Jasmine, it basically runs in the browser, so you have to worry about setting up and tearing down. Here, everything's isolated. And you also can do unit testing and UI testing in the same tool. So we do a lot of this. For example, like pure data testing is done easily in unit tests, but we can also swap into UI tests and render stuff to the DOM, click it, drag it, type into this text field. Very easy. And the entire tool itself is just written in JavaScript, so you can run it in any browser easily. And the source code is fully there, so you can change it and patch it and play with it and extend it as well. Test any JavaScript, jQuery, Node. Of course, the prime case for us writing it was that we wanted it to be good in understanding Sencha code, because in Sencha, everything you see is generated on the client. The server doesn't really output any static, like known HTML that you can trust. But we build special adapters for XJS, an event recorder where you can start dragging and clicking in the UI, and we'll record that and actually produce code. I'll show that in the end. So a bit about the Sencha awareness. So we have methods that you can use that are very highly abstracted, so that actually sounds like a sentence, like wait for stores to load, and then you pass in one or many level store instances, and then a callback when it's done. Wait for rows visible. That sounds a lot better than just say wait for some CSS magic selector that nobody really understands. So we've abstracted away the whole thinking or understanding of ext. So we can now just say wait for event. Maybe there's some list of fire selection change after click. Stuff like that. So test code organization is also something very important, and BDD is really, really good for this, because if you just write your test really quickly, they get unmaintainable. And you have to treat your test code as your product code, because it has to be documented, has to look nice, other developer has to be able to understand it, otherwise it gets forgotten and just collects dust. So here's what you write when you write this style. You say describe what you're testing, maybe the user model or the order entry form, whatever you want. And then you do these nested if statements, like you instantiate some user and then fire away your expectations. And hopefully you'll have passing tests. So, like I said, a Siesta unit test is just pure JavaScript, contain any JavaScript code, should be wrapped in either a start test or a describe function. This function is called when all the preloads, all the requirements for this test is ready, so you can think of it as the document onload function or the ext onReady callback. And this is the most simple use of Siesta, where we just do comparison of numbers. Is 1 equal to 1? Isn't for not equal. Like for string matching. Throws OK to verify that some function should throw an exception. Lives OK for the opposite. Is deeply to verify deeply structured like objects and arrays. Very basic stuff. All of this can be found in the Siesta examples folder as well. And when you do your unit test, you really want to focus on the model level and the utility level first. You don't want to go too extreme and start worrying about the entire application. You want to go piece by piece. So that means your entire code base will eventually be tested, which gives you the best value for your money. Because typically in Xtap you reuse your stores, your models in many places, so having them covered will have a benefit in many places of your app. And then once you're done with that, the lower stuff, you can just move on to the UI, the visible things, like click your user list or drag a photo around, some higher order stuff that's a bit more complex. And of course, a general rule is the more code you execute, the less easy it is for you to find the bug, because there's just more going on. So something to think about, like keeping your tests as small as possible, also for readability, of course. And then, of course, there's another thing called application tests. How many of you have used Selenium, for example? A few. So that's like a different concept. That's when you fire up a testing tool, go to this URL, google.com, and do these commands. So that's a quite different beast to tackle. We support that too. Of course, since we're now running the entire application code base, it's going to be a whole lot harder to find these errors, because now we're doing everything. We're loading every module, of course. So if there's a bug, it might take a bit of time to find and zoom in. Of course, it has a really high value, because this will tell you, can I ship? Does my application work at all? So this is, of course, what the manager will care about, because if they can't release them, that's not a good day. So a simple unit test looks like something like this. Just describe it as a JSON tree, group it by some group, whatever you want to call it, infinitely nested, of course, and you state your requirements. Like in this test, I want class 1 and user.js to be loaded, so they will be loaded in order, and then once that's done, the user t.js will be launched for this group. And again, this would be a very simple test for if you have a user class in your JavaScript code base. You just instantiate a user and test it that its properties are there, or whatever domain logic you have in your application. And UI tests are a bit more visual, of course, so they involve the DOM, because you have to render things, you have to see them. That's already a couple of levels up in complexity, because the DOM is a beast. It's slow. So we do typically 3 things. We do user interactions, like click this button, type into this name field, and then we have to wait, because we usually wait for some animation, maybe some AJAX request to finish. And then once we've done a bunch of stuff, we have to assert. So did the database update? Did the window move to where we dragged it? So that's the assertion. So we do 3 things in UI tests, mainly. And we advocate a lot that you test your parts of your application, like your individual components, your subclasses. Put those in one test and test them in isolation. Because that gives you also a very nice way to find tight coupling. If you can't render a user grid without user form existing, then that's a bit too tightly coupled for most people's taste. So these chains that we call them, that describe the actions you want to do with your tests, they are just completely asynchronous. So you can do any sequence of steps using the chain command. So each step in that queue can be an object or a function. So since we have a function, we can do anything. We can execute any code we want. And each of these functions receive a continue callback, which you can use to continue, because you might be doing asynchronous stuff inside of your function that Siesta doesn't know about. So this is what it looks like, the most simple chain. So this is just saying action, click, pointing to some target. That target is here a CSS selector, some ID. And then we can do whatever we want in that function, like we can have assertions, we can call any JavaScript, of course. This is pure JavaScript, no magic. And we can just call the next as a callback, because the click action itself is asynchronous. First the cursor has to be moved, that takes a bit of time. Once it's over this target, click. And then after that, the callback is called. So, simulating user input, we use these action commands. So, we have plenty of methods to wait for selector, to wait for some CSS selector, click somewhere, type, foobar, special characters like enter, escape, we can do that too, all uppercase. So, this is a very typical like login case or entering a form. So, this is all done in pure JavaScript. And you also needed to know a bit about how to target stuff in the DOM. So like I said, we have EXTJS layers that help Siesta understand how to reach things that you see on the screen. So you can feed any of these into the Siesta engine and it will understand what you mean. So you can give it a component query selector, CSS selectors, a coordinate, which is of course a horrible idea, because if the designer makes the button half the size, then goodbye test. So you want to make your tests as robust as possible. So the higher at the abstraction, the likely it will stay working in the future. So yeah, these are plenty of choices to write your targeting for interacting with the screen. So a few samples, getting an HTML element. I guess you've seen document get element by ID, or the X version XGet. We have a CSS selector, some div.foo or hashtag for ID. Component query, which we prefix by double arrow, and our own special composite query, which is a combination of component and CSS query. So quite a lot of expressive freedom in targeting the screen. And these are all valid Siesta chain commands, clicking different buttons using all the ways we can. Like there's an array at the top, which is really bad. Then the ID of a grid, and then the grid instance itself, the DOM element, etc. So, and you can also point to a specific point inside of these targets, like give me middle, and you can say 50% -5. If you want to click somewhere close to the edge, maybe some user reported a crash, like when you click the right side of a text box, there's some special trigger. So you can have down to the pixel here, and 10 from the left edge. So yeah, lots of targeting power in it. And again, waiting is something that you will do a lot in tests, because you have to wait for maybe the application to load. You have to verify that all the stores are ready, that the ext is ready. So there's a lot of waiting involved in your tests. There's no way you can get around it. So there's over 40 wait commands built in, and you can of course build your own. That's the whole power of Siesta. You can extend it to add your own custom domain tests. And yeah, this is some way you can do testing of waits in a chain. So you can wait for a selector, because maybe your initial login screen has some known CSS class that you can wait for to prove that it's actually present in the DOM before you start typing username, mic, password, 123. Wait for event, wait for hard-coded number, something you shouldn't do either, because things will take different amount of time, especially under load. So stay away from that. And code quality is something we care quite a lot about. It's very tricky to keep a code base looking nice. A, when you're not in the same room. B, working with JavaScript, because it's just so easy to screw up. You forget one comma and IE says goodbye. So we have a lot of tests to catch these basic errors from even getting into the code base first place. So I wrote something that I put on GitHub. If you want to go to my account later, you can have a full suite doing all these things. I'm not going to go into the details of monkey tests. All right, but you can all guess what it's like, right? So you take a laptop, you go to the zoo, you bring a banana, you give a banana to the monkey and says, just do like this for 10 minutes, like bang on it. And the monkey will do that and probably find bugs. That's the whole theory behind it. So Siesta supports that. We can just say monkey test, point to any target grid, and then how many interactions. And you don't have to pay any bananas, anything. So it's going to click and drag and type just randomly in random pixel coordinates. And this has found us lots and lots of bugs for free. So we do this every night. And that's very cool, because one of our products is a scheduling, a Gantt chart, which comes with about 40 examples. So we put the monkeys to use for each of those samples and say, hey monkey, click here for 10 interactions. And then the monkeys do that, and we get emails back if they find anything with a full stack trace and what the monkeys actually did, so we can just make a test out of it in no time. And it costs us nothing. We wrote one line of code, that's the cost, so it's pretty cheap for finding at least 20 bugs in the last 2 years, I think, which is before we actually ship. That's the whole point. So we don't have to have the clients be mad and shout at us. And like I mentioned, we have 40 examples, so they are online, where people can try them out and see if they're good or not. And again, we have exception logging turned on to those examples. So if there's something going wrong online on our site, bryntum.com/examples, we're getting an email sent with like what's going on here, which is also free testing help. So we're basically using our customers to be as our test resource for free. And this is something, unfortunately, I got the other day. What was it today? Yeah. This is an error report from our online checking system, which gives us the message, URL, what line it happened, which browser, which product version of ours, what's the local date, because we're always curious about time zone specific bugs, because they take so long to hunt down. So we can get that from just typing new date to string. Too easy not to do. And the window size can also matter. So why not get that too while we're sniffing away. So this is also just free labor. Because we're such a small company, we can't have a testing department. We don't have the money. Pre-commit hooks are pretty awesome if you want to stop bad code from getting to your repo, which you typically do. And as part of your build step, you will just copy this commit hook to each developer's Git folder, for example, and that will ensure that every developer has the same hook. That's the whole point. And yeah, so it shouldn't be too easy to break the build. That's the takeaway. So for our pre-commit hook does 3 things. We're doing JSON, which is just a syntax check. This is our bash script, actually. Feel free to take photos. Just takes all the checked out files and does a JSON simple check for it. The second step we have is that we have a check to find specific keywords in our tests. And one thing that we don't want to check in is the IIT statement, is when you want to isolate a specific test section to just focus on getting one test to work. It's very easy to then, hey, it works, commit, before you say like, hey, whoops, now the other tests aren't running. So that's something we want to catch and not commit at all. And the third one is we do a couple of smoke tests. So we run the most critical tests to make sure that if we bring a new guy on board, he shouldn't be scared of changing things in the core, like the date manipulation algorithm and logic. That should be safe. So we run about 1,000 tests for each commit, just to be sure that the new guy didn't go bananas and, I don't know, go crazy. So very easy. All this stuff is from our own builds. And of course, when you have written a test suite, it's only the fun part left, and that's doing the automation, because you don't want to be clicking it in 58 browsers every day. So we can launch Siesta using PHANTOM.js or Selenium for in-IDE use, like WebStorm, Eclipse. We recommend Phantom because it's faster. And nightly builds and continuous integration, you should probably use a real browser because you want to know the real value. And this is what it looks like when you run it on your prompt. Just PHANTOM.js firing up, giving you the results. And with the possibility to get IDE integration, you are able to save a lot of time as well. Because at the end, you don't want to go back and forth with Chrome or Firefox and then, okay, I have to go back to the test again and change it. Oh, okay, let's test it. Okay, gotta change the test again. That just takes too much time. So this is what it looks in my WebStorm environment, where I have a single key command that I can fire up to run the current test that I'm working on. So I don't have to think about UI too much. I can just do it inside of my favorite development. And any tool can do this, like Visual Studio or Eclipse or Spigot, Aptana, whatever you want. Yeah, all of these work, of course. A few notes about code coverage. This is what it looks like once you have the code coverage module installed on your XJS codebase. You get a nice tree visualized. All this is done in XJS, by the way, so it might look familiar. That's a charting package on the right. So we can see, maybe it's too hard to read, but what if we zoom in here? You see different parts of the code base has different coverage. And again, we're not really interested in the parts that have 100%. That has no value at all. We're interested in the 0% ones. So those should never appear at all in the first place, and never in your core classes, like the stuff that's really business intensive, your business logic, or the most busy screens of your applications should of course be covered a lot. And if you want to zoom in to look at one class, then you get it shown on the right side like this. Again, we use Istanbul to do this, which is pretty cool. And you get the lines highlighted in red if this was not called. So you get pretty good details. And then you can just take it back and iterate and write more tests and do coverage reports again. And the final bit that I want to mention is that we have an event recorder, which helps you skip the tedious process of writing UI interactions. It takes too long. And this also gives you stable targets, which is the challenge of using Selenium, because Selenium has no clue what Ext is, it just knows about HTML. So with Siesta, we can actually translate this DOM element to some higher order, some button, some grid, a grid column. We know all that stuff. And this is available only in one of our latest releases, so you'll have to go to bryntum.com/product/siesta to get it. And this is what it looks like. It's just a grid with a bunch of actions that you can later change to update the targets. Maybe you click the wrong place, or you want to drag it a little bit less, you want to change the name you typed, you can change that after in runtime. And then this will also generate the code for you that you can put back in your tests and smile. So with that, I want to just switch over to show a bit about what this looks like. So I'll switch it to slow mode and see if we can get this. So the UI for Siesta is built all in Next.js. And this is one of our tests from our own product called the scheduler, which is, I'll just show you, it's just a booking component where you can just type in things. So this is just a resource calendar view. One of the popular things we have is this editor window. So this test is covering only this editor window to make sure that it actually works when we ship. Because if this doesn't ship, we will get one angry call per client at least. So the test looks like this. You can see the mouse being moved, clicking, making sure the editor moves when you click events. It types and saves. Testing the delete, creating a new one. So that's kind of an extensive test that tests every aspect that this widget can do. And you can run it over and over in any browser. When you're tired, you can leave it to the machines. So this is actually part of our test suite. And you see the whole nested tests where you get these collapse expand buttons where you can dig into the test to see each subtest, what happened in that subtest if there was a failure. We have the component inspector, which helps you learn about what's actually in the screen in XJS, like not worrying about what's a div tag, what's a button tag, but what's the XJS way here. So this is a time axis column, it's a grid column, it's a grid view. And you can actually go from here straight to the docs. So this is a great thing for a beginner. So we take you straight to the docs of this class on sencha.com if you want to learn more, which is a good thing if you're a tester not really familiar with Sencha at all. So that's how a UI test looks. And I want to show you also the recorder that we have. So what if we have this screen? This is our application that we're going to test. Let's say I want to drag a few of these bars around and make sure that this actually works. I'll just go over to the recorder. Let's clear this for now. And start recording. Drag this one a little bit, drag that one a little bit, drag this one. That's enough. Now we can play it back. And you see it's doing exactly what I did, and I didn't have to type a line of code. And it took like 4 seconds-ish. And now we can go in here and we can actually change these values. If we want to click maybe the second row, just zoom in a little bit so you can see the text. I can change the selector here, and that immediately shows you in the DOM like what's going on here. What am I going to click if I go to the second row? This is basic CSS, which most of you already know. That's pretty much it for the demos. So I just want to say thank you for listening and coming. And that's actually 8 p.m. sharp. Nice. Just luck, actually. So, any questions?
Will you make your presentation available?
I will, yeah. I will. I can actually do that right now. Export the PDF. That's the URL that is going to be found. My speaker deck account. Sign in. Don't ask for my password. Did I forget password? Oops. Oh crap. Sign in using Meetup. Upload. Sencha, Oslo, Meetup. Oops. And that should be it.
Okay.
All right. Thank you very much.
Do you do tests on mobile devices as well?
Yeah.
Yeah.
Not native, but there's a simulator we can use. But mainly we use actually the Chrome for our Sencha Touch test, because it's so close to. Because we don't really test the lower levels that Sencha Touch is providing, like the cross-browser thing. That's already Sencha's domain. We just test our code basically, which is a bit easier. But there's a project called iOS Driver that is Selenium way to help you test mobile devices. It's pretty cool. There's
How long
also-
it takes to run all the tests?
It takes you
UI tests.
26 minutes for our biggest one. I'll actually show you an email. Our current system is using email, so this is our Gantt report from today. This is the results. So we just dumped the Chrome version, and we have 10,000 assertions, which takes 50 minutes. And this is using, so for every version of X, that's a duplication of our suite basically. So we support 2 versions, so the full run is taking 26 minutes. And the Windows Firefox. So you can actually see which browser is a bit faster too. So Chrome, Firefox are expected to be good. IE not so much. IE10 is pretty good actually. So
You have a different number of tests for different browsers. So you do test some browser specific.
yeah, we have some edge cases like that, but normally not. But
DOM related, probably.
probably yeah.
No.
There's still some stuff that's unexplainable in IE.
No. Never.
Yeah. So
You mentioned some wait for statements
yeah.
that you have. What do you use to wait for events to happen? Like when you wait for some selector, do you actually browse DOM
Yeah.
continuously?
So, no, we use X, or yeah, we use jQuery for that actually.
Okay.
So I can say that's t.wait for selector, for example. Pass in some foo, and then what should happen after.
Mm-hmm.
So this should just hang now. So this is a bad test to run. Now it's not going to finalize. As you see, it's still trying to find it. do set timeout
Okay. Yeah.
function. So document.
Is it easy to write custom wait for?
Yeah, absolutely. We have a lot of those for ours.
Mm-hmm.
Like, for example, our Gantt chart. Before we start the test, we want to verify that it's, the tasks are displayed, the links are displayed. There's no point in trying to interact with them. So we have wait for tasks visible,
Yeah.
wait for events to render. We have all those, because that's the whole point. You want to write your own DSL on top of Siesta so that the tests become very neat and short.
Yeah.
Otherwise, big, huge tests are just a pain. So this should clear this test. So now you say it takes a second for this to time out, right? And then we just introduce this class in the DOM, and we're done. So very, very easy. I can actually show you our wait for. This is our wait for command, which we have abstracted. This is not part of Siesta. You can't find it unless you get our products, which also gives you our test suite. So this is this is how it works. Anyone else? Any questions?
If we think about JavaScript testing tools like JSLint, how is Siesta different?
So JSLint is a syntax validator. So that's a bit different. That should be built into your IDE. But we have a test for that too, just in case it bypasses. Maybe some of our developers is just taking that out. They use some really bad version of Eclipse that don't have JavaScript. So just because my trust is low, we have our own sanity test which runs this as well. So that nobody should be able to trick this. So we have a lint test which just does an AJAX request, fetch the source file, all debugged, and then we load the rules for our JSINT so that we all use the same rules, and then we apply this test. So I can run it right here. Hopefully now it's passing. So if somebody were to check in, well, they can't check in because they're right. So I actually have to change it myself because the pre commit hook will prevent me from checking in crap, so which is good. But I'll just modify it myself. There's this bug. So if I do something really bad and stupid in here, let's go to the
Debug.
So, something like that should not make it pretty especially good. So now we have a test giving us the red flag immediately. Just as a last line of defense, because this is so cheap. I like doing stuff that gives me infinite reward. And this I write once and it's, I don't know, 30 lines of code. I can take that. And it's not even complex code. It's fetch file, do JSINT. This one. That's the whole. So it's just nice to know that when you come to work, somebody won't have broken the build and it didn't cost much. You can't say this is too expensive. Anyone else?
Is Siesta a commercial product?
Yes. So we offer a free cheap version, which allows you to get started. It includes most things, not the recorder and not the automation part. Then it's $500 per developer if you want to use it. And you will probably save that in a couple of weeks after it finds bugs for you. But yeah, if you talk to your managers about this, they have to understand that testing is an investment. That argument is really valid. It takes time, it takes money. It's going to pull people away from making awesome features. But then down the road, it's going to save so much embarrassment in bugs coming back and just developers working faster because they know they can trust parts of the code base in a way that they could never before. So our productivity now, speaking for our team, it definitely doubles because we don't have to go into deep to debug parts because we know they are actually covered really, really well. They should not be possible to break. So we look in the right part when debugging immediately because we know what's fresh, we know what's not tested very well. That's a good place to start looking for. Yeah, we become better Sherlocks. So, but yeah, managers will most likely say no to tests because it takes away time from writing features, which means writing new bugs, because programmers aren't perfect, at least I'm not.
This runner for IDE is just for passing test. It's just normal settings, or it's your plugin?
It's just Phantom. So all I'm doing here is, you see, launching Phantom 2.js.
So you just run command line?
Yeah, this is just command line. There's no plugin, nothing. So it's just completely headless.
Great.
Right.
Thank you.
Right, thank you again.